Right. Hi, Jess. Thank you so much for agreeing to talk about your work on the VR School project, in particular using virtual reality for mathematics. Uh, if you'd like just to tell us a tiny bit about yourself and your professional background, and then talk a little bit about how you approach using virtual reality to teach mathematics.
Thanks, Erica. I am currently the assistant head of mathematics at Trinity College, and I have always had a really keen interest in utilising digital technologies in different ways, in particularly in my areas of science and maths. And so I've always wanted to find different ways and innovative ways of incorporating that for 21st century learning. And so when this project came up, I was very excited to be able to incorporate it in mathematics, which I think we'll realise is very traditional in its methodology. And so being able to apply virtual reality into mathematics has been a really interesting experience. There's been lots of trial and error and lots of different ideas about how to actually incorporate it. And so for me, I decided to incorporate it in a Year 9 mathematics class, looking at linear and non-linear equations and looking at the graphs for those equations. And I really wanted the students to be able to map out their own space, their own physical space, and how graphs can be seen within those lived environments. And I had a real big interest in having the students engage with that independently, without me telling them what they needed to incorporate and where they needed to go with it. So it was very much they had massive collaboration with each other, and they were able to find those key graphs within their environment. They took their own 360 photos of that and created a virtual reality world in a way that was used as a resource to teach other students about the graphs in a very visual and very interactive way. And a big key thing we looked at was creativity and how creativity can be used in mathematics. And throughout the whole assessment task, the whole unit, we found that students were able to articulate creativity, they were able to articulate how they could apply it in mathematics, and their confidence in being able to understand and use creativity really increased throughout it as well, with being able to use virtual reality as a method for showing their creativity in mathematics.
Fantastic. So could you give me an example of one project that a student or a group of students created?
So one of the projects, the students took photos around the college and they used the graphs in a way that also implemented a storyline. So they looked at a murder mystery throughout the school, but they had to solve equations around the place using the ramps they saw for a linear graph, or the sculptures around the school that was circular, and they had to describe what a circular graph would look like, what the formula would be. And they left clues within that, and they created a murder mystery that it was a kind of choose your own adventure. You know, you found the correct answer, which led to the next clue, to the next photograph that they took. Another group they were very interested in sport. So they looked at the graphs of sport. So they threw basketballs up and they created animations that flowed with the parabola, the path of a basketball. They looked at javelins and how javelins can, how they stick into the ground. So they looked at just different ways that sport could be utilized. So they not only used their creativity in how they found the graphs, but they used their creativity in how they told the story of their learning to be engaging for the users that they were also designing it for.
So they looked at the environment around the school and looked at the ways equations could be represented in the everyday world of the school, in fact, in order to teach others about what would I imagine would be quite a difficult kind of concept for many students.
Yeah, that was the whole idea of it, really, was to see, there are examples of straight lines and parallel lines and triangles and all this stuff around our world. And by making it relevant and real life and making them go seek that, they also learnt that actually, if I did this, the ramp is this steep, the equation for this ramp would need to be this. But if I lowered the ramp, so, our students with disabilities with wheelchairs could use the ramp, then, you know, it might be more accessible for them. So they were able to make these connections as well in just their built environment. And it was just really interesting to see where they went with those ideas. And afterwards they were able to go, oh, well, this would be this kind of graph because you'd use this shape for it. And it was really nice to see how they made those connections within the context of the school and with mathematics.
Because VR is really a kind of spatialized type of technology, spatialized form of media, I suppose. And so understanding how to, where it might fit best with the curriculum in understanding space and but mathematical contexts would be quite important. So how did you go about choosing the area of mathematics that you would use VR with? What did you have to consider?
Well, it was definitely the spatial idea of that and how graphs could form in the real world and in the 3 dimensions. I think with a lot of practical tasks, we tend to go towards measurement, or we tend to go towards stats because we can find relevant places. So I wanted to stay away from those two because I wanted to find something that was a bit more abstract to be able to bring into relevance with this. And so graphing ended up being a really good one because there were still spatial aspects. The students had to consider the environment around them, but there was also the rigor of mathematics too. They needed to know the graphs they were forming, the equations that went with it, the transformations that went with the graphs, and how that applied to their built environment. So they had to explain all of that in the assessment, as well as finding those examples. And I think a big concern people sometimes have with maths is it's not going to be rigorous if we do all these practical tasks. But there was so much rigor embedded in this because the students needed to know and needed to understand the concepts behind what they were doing, but then they also needed to apply it in a creative way. And they needed that background knowledge to be able to find, well, I know this shape forms a circle, but then there's a smaller circle here. How does that transform? What changes about that? And that was really important within the assessment. They had to be able to explain that.
And they had to explain it because they were developing a resource for others to learn with. So they had to know their content and their the kind of abstractions in depth, didn't they, in order to be able to do that?
Yeah, it was a really big thing for them to need to be able to do that but they needed to be able to explain it in a way that was applicable for the other students as well. So it couldn't just be a regurgitation of the textbook. They had to be able to apply that in a way that was meaningful and understandable for their peers.
Yeah, that's fantastic. So what advice would you give other teachers who might look at this technology VR and think, well, where would it fit with my curriculum and in my subject area?
I think you need to be creative as well. As teachers, we need to be able to find some creativity in what we do and be brave and just try it in a different way. The first iteration I did of this didn't work as well, and I tried it again and it worked differently this time. And it's all about trying what's new, trying what's scary, and finding where it fits for your context as well, because sometimes it won't work for, the same idea won't work for everyone. But also giving the students agency to be able to do what they think as well. Having students explain, actually, maybe we could do this here, and allowing their creativity to come through. It's a really meaningful experience as a teacher to see students take that and roll with it and go places that I didn't even consider either.
Thank you so much, Jess.
Thank you.